What if I told you the biggest technology story of this year isn't a new AI model, it isn't another NVIDIA GPU, and it isn't the next iPhone. It's something almost nobody is talking about. China quietly patented the future. Now, when most people hear the word patent, they imagine boring legal paperwork sitting in a government database. But the world's biggest technology companies don't spend billions filing patents for fun. They file patents because they believe those ideas will become products. And right now, China is filing patents across artificial intelligence, semiconductors, robotics, autonomous vehicles, advanced batteries, optical computing, and brain-inspired chips at a scale that has shocked analysts around the world. Here's the part that made me stop scrolling. China has become the world's largest holder of AI-related patents, not by a small margin. By a margin so large that many experts now see patents as a window into China's long-term technology strategy. But this video is not about counting patents, because a patent count alone tells you almost nothing. A country could file thousands of patents that never become useful. The real question is, what is China actually patenting? And when you start looking at the answers, the story becomes far more interesting. Imagine walking through a giant warehouse. Every locked door contains a technology that could shape the next decade. Some doors contain AI chips, some contain humanoid robots, some contain new battery systems, and some contain ideas that haven't even reached the market yet. China's patent filings are like labels on those doors. They don't show you everything inside, but they reveal where the country is investing its attention. And one of the clearest signals comes from semiconductors. For years, the dominant narrative was that China was permanently behind in advanced chips. Then export restrictions arrived. Many people assumed that would slow China down. Instead, it triggered a massive push into domestic chip design. Companies like Huawei began filing patents related to AI accelerators, chip packaging, interconnect technologies, and energy-efficient computing. At the same time, Chinese researchers and companies increased work on RISC-V, an open-source chip architecture that allows countries and companies to build processors without relying on proprietary licensing models. And suddenly, a question that sounded impossible a few years ago became a serious discussion. Could China build a largely independent AI computing ecosystem? That question is no longer theoretical, because we're already seeing Chinese AI chips appear in data centers, cloud platforms, and industrial systems. But the patents suggest something even bigger. They suggest China isn't just trying to catch up, it's trying to redesign parts of the AI hardware stack itself. And that's where things start getting strange. Because some of the most interesting patents aren't about making today's chips faster. They're about building computers that work differently. Brain-inspired computing, optical computing, new AI architectures that could reduce power consumption dramatically. Think of it this way. Most AI systems today are like giant trucks burning enormous amounts of fuel to move data around. China's research patents increasingly point toward vehicles that use less fuel, move information more efficiently, and in some cases imitate how the human brain processes signals. That doesn't mean those technologies are ready tomorrow. Many are still in research stages, but patents reveal where engineers believe the next breakthroughs might come from. And semiconductors are only the first door, because the second door contains something much easier to see. Robots, not factory arms hidden inside industrial plants. Humanoid robots designed to walk, carry objects, and eventually work alongside humans. Over the past year, Chinese robotics companies have accelerated development at a remarkable pace. Some are already deploying robots in warehouses, manufacturing facilities, and logistics operations. Others are training robots using AI models that learn from human demonstrations. And when you connect those real-world deployments to China's growing portfolio of robotics and AI patents, a larger picture begins to emerge. This isn't a collection of isolated inventions. It's an ecosystem. AI chips powering robots, robots generating data, data improving AI models, and new patents feeding the next generation of products, which raises a much bigger question. If patents are a map of future technology, how many of China's most important inventions are still behind locked doors? Because in the next part, we're going to open the robotics door. And what Chinese companies are building there may be the clearest sign yet that this race is no longer about smartphones. It's about who builds the machines that will work with humans in the AI era. China's robotics story didn't begin with flashy humanoid robots dancing on social media. It started somewhere much less exciting: factories. For decades, China's biggest advantage was manufacturing. Millions of workers, massive production lines, and the ability to build almost anything at incredible speed. But as wages increased and the population began to age, China faced a difficult question. How do you keep the world's largest manufacturing engine running when human labor becomes more expensive and harder to find? The answer wasn't just hiring more people. It was building machines that could work like people. That's why many Chinese companies weren't trying to create robots just for impressive demonstrations. They were creating workers. Imagine owning a factory that operates 24 hours a day. Now imagine replacing repetitive, physically demanding jobs with robots that don't get tired, don't need breaks, and can continuously learn new tasks through AI. That's the future many Chinese companies are investing in, and their patents reveal just how serious that effort has become. Companies are filing patents covering robotic hands with greater dexterity, vision systems that help robots understand their surroundings, motion control, force sensing, and AI software that allows robots to adapt instead of simply repeating pre-programmed movements. Think of older industrial robots like music players that can only replay the same song. Modern AI-powered robots are more like smartphones. You can keep giving them new abilities through better software and better AI models. That's a completely different way of thinking about automation. And we're already seeing that transition happen. Companies like Unitree have gained global attention by building humanoid robots that are becoming more capable every year. UTech has focused on industrial humanoid robots designed to assist in manufacturing environments. Meanwhile, companies such as Agabot are pushing rapidly into general-purpose robotics, aiming to develop machines that can perform a wide variety of real-world tasks. None of these companies claim they've solved robotics. Far from it. Today's humanoid robots are still limited. They move slower than humans. They consume a lot of power. And many tasks remain incredibly difficult. But that's exactly why the patents matter. They're not snapshots of what robots can do today. They're blueprints for what engineers are trying to solve next. Every patent represents another attempt to improve balance, increase battery life, reduce manufacturing costs, improve machine vision, or make robots safer to work alongside humans. And here's where the story becomes even more interesting. A robot is only as intelligent as the computer inside it. That's why China's investments in AI chips and robotics are deeply connected. The chip processes information. The AI model makes decisions. The robot carries out the action. It's like building a human body. The brain is useless without muscles. The muscles are useless without a brain. China isn't just developing one technology at a time. It's building an entire ecosystem where each breakthrough strengthens the others. More robots generate more real-world data. More data trains better AI models. Better AI requires better chips. Better chips make smarter robots possible. Then the cycle starts all over again. It's a feedback loop that becomes stronger with every improvement. And the impact goes far beyond factories. The same technologies are being explored for warehouses, hospitals, logistics centers, power plants, and even elder care. Whether every one of those ideas succeeds is impossible to know. But the direction is becoming increasingly clear. China isn't simply preparing for the next generation of manufacturing. It's preparing for a future where intelligent machines become part of everyday infrastructure. And if robots are changing how things are built, the next technology is changing what those things actually are. Because one of China's most aggressive patent races isn't happening inside robotics labs. It's happening inside batteries, electric vehicles, and autonomous driving systems. And what Chinese companies have built there has already started reshaping the global auto industry. China didn't just become a giant in electric vehicles by building more factories. It changed the rules of the game. For years, the global auto industry followed a familiar formula. Build a better engine, make it more efficient, sell millions of cars. But when the world began shifting toward electric vehicles, everyone started from almost the same place. It was like pressing the reset button on an industry that had existed for more than 100 years. And China saw an opportunity. Instead of trying to dominate yesterday's technology, it focused on tomorrow's. That meant batteries, electric drivetrains, power electronics, autonomous driving, and the AI systems that connect all of them together. Today, many of the world's largest EV manufacturers and battery companies are Chinese. But here's what often gets overlooked. Behind every new battery chemistry, every fast-charging breakthrough, every intelligent driving system, there are years of research and thousands of patent filings. Those patents aren't just protecting products. They're protecting entire technologies that could shape the next decade. Think about a smartphone for a second. You don't buy it because of a single feature. You buy it because hundreds of technologies work together. The same is true for modern electric vehicles. The battery, the cooling system, the AI computer, the cameras, the sensors, the software, the charging technology. Every one of those systems is the result of countless engineering decisions. And China has been patenting improvements across nearly all of them. Take battery technology. For many people, a battery is just something that stores electricity. But engineers see something completely different. They see the biggest challenge standing between today's EVs and tomorrow's transportation. How do you make batteries charge faster, last longer, stay safer, cost less, work in freezing winters and scorching summers? Every answer to those questions can become a competitive advantage. That's why Chinese companies have invested heavily in battery research, from new cell designs to manufacturing techniques that improve efficiency and reduce costs. The goal isn't just to build better batteries, it's to make electric vehicles practical for millions more people. Then comes autonomous driving. Most people think self-driving cars are simply about cameras and sensors. But the real challenge is decision-making. Imagine driving through a busy city. A child runs toward the road. A cyclist suddenly changes lanes, traffic lights, construction zones, rain, fog, unexpected obstacles. Your brain processes all of that almost instantly. Teaching a machine to do the same is one of the hardest engineering problems ever attempted. That's why modern autonomous vehicles rely on enormous amounts of AI. Every mile driven creates more data. Every difficult situation teaches the system something new. And just like we saw with robotics, that creates another powerful feedback loop. More vehicles generate more driving data. More data improves AI models. Better AI creates safer driving systems. Safer systems encourage wider adoption. Then the cycle repeats. Some Chinese companies are already deploying advanced driver assistance systems across millions of vehicles, while continuing to develop more capable autonomous technologies. Fully autonomous driving still faces major technical and regulatory challenges around the world. No company has completely solved it. But the patents reveal something important. China isn't waiting for the future to arrive, it's actively designing it. And by now, a pattern should be impossible to ignore. Whether it's AI chips, humanoid robots, or electric vehicles, these aren't isolated industries competing on their own. They're pieces of a much larger puzzle. A puzzle that leads to perhaps the most fascinating patents of all. Because some Chinese researchers aren't trying to improve today's computers. They're trying to invent entirely new ways for computers to think. If you've noticed something about every technology we've talked about so far, you're not imagining it. AI chips, humanoid robots, electric vehicles, autonomous driving, they all have one thing in common. They still rely on the same basic idea that's powered computers for decades, move data back and forth again, and again, and again. The problem is, modern AI is becoming so large that moving information is starting to consume almost as much energy as processing it. Imagine running a restaurant where the chefs are incredibly fast, but every ingredient has to be carried from a warehouse miles away. Eventually, the chefs aren't the bottleneck anymore. The delivery trucks are. That's exactly what's happening inside many AI systems today. Engineers even have a name for it, the memory bottleneck. And if AI continues growing at its current pace, simply making chips smaller may no longer be enough. So researchers around the world have started asking a much bigger question. What if computers didn't have to think this way at all? This is where some of China's most fascinating patents begin to appear. Instead of copying traditional computer designs, some researchers are trying to copy something far more efficient, the human brain. Your brain runs on roughly the same amount of power as a light bulb, yet it can recognize faces, understand language, learn new skills, and make incredibly complex decisions in real time. Even the largest AI supercomputers consume vastly more electricity to perform similar tasks. That gap has inspired years of research into what's known as brain-inspired computing, instead of processing information exactly like today's computers. These systems attempt to mimic certain principles of biological brains, making AI potentially more efficient for specific types of workloads. Chinese universities, research institutes, and technology companies have published research and filed patents exploring these ideas. Some focus on neuromorphic chips, Others explore new memory architectures. Some investigate AI hardware that processes information in ways that could dramatically reduce energy consumption for particular applications. None of this means your next laptop will suddenly work like a human brain. Most of these technologies are still experimental. Some may never become commercial products, but that's exactly why patents are so valuable. They reveal where scientists believe the next breakthroughs could happen long before consumers ever see them. And then there's another technology that sounds almost like science fiction: optical computing. Today's computers move electrons through tiny circuits. Optical computing explores using light to perform certain calculations instead. Why does that matter? Because light can move enormous amounts of information with incredible speed and efficiency. If engineers can solve the remaining challenges, future AI systems could perform some tasks faster while consuming far less energy. Researchers across the world are investigating this field, and China has become one of the major contributors through academic research, engineering development, and patent activity. Again, that doesn't guarantee success. Engineering is full of brilliant ideas that never leave the laboratory. But when you step back, a fascinating pattern begins to emerge. China isn't placing all of its bets on one revolutionary invention. It's investing across dozens of possible futures at the same time. If one technology struggles, another may succeed. If one path reaches a dead end, there are others already being explored. That's a strategy, not a single breakthrough. And when you combine advanced manufacturing, AI chips, robotics, electric vehicles, brain-inspired computing, and optical research, the patent filings start looking less like isolated inventions and more like pieces of a long-term blueprint. Which brings us back to the question we asked at the very beginning. Was this ever really a story about patents? Or were the patents simply the breadcrumbs leading us towards something much bigger? At the beginning of this video, I told you that China quietly patented the future. Now you know why. This was never about winning a competition over who could file the most paperwork. Patents don't build robots, they don't manufacture chips, they don't power AI. People do, engineers do, researchers do, companies do. But patents leave behind something incredibly valuable: a trail. A trail that shows where those engineers are trying to go next. And when you follow that trail across artificial intelligence, semiconductors, humanoid robots, electric vehicles, brain-inspired computing, and next-generation AI infrastructure, a much bigger picture begins to appear. China isn't betting on a single revolutionary invention. It's building an entire technological ecosystem where every breakthrough strengthens the next one. Better chips power better AI. Better AI trains better robots. Better robots improve manufacturing. Better manufacturing builds better chips. It's a cycle designed to accelerate itself. Does that mean China has already won the global AI race? No, not even close. The United States continues to lead in many critical areas, including frontier AI models, advanced semiconductor design, and several of the world's most influential technology companies. Europe remains a leader in specialized engineering and industrial technologies. Japan and South Korea continue to dominate key parts of the semiconductor supply chain. This isn't a one-country race. It's the biggest technological competition the world has seen in decades, and that's exactly why these patents matter, because they give us a glimpse of what each country believes will define the future. Some of those ideas will fail, some will remain locked inside research labs forever, and some may completely change the way we live. History has shown that today's impossible idea can become tomorrow's everyday technology. There was a time when smartphones sounded unrealistic, when electric cars seemed impractical, when artificial intelligence felt like science fiction. Today, they're part of daily life. So when researchers file patents for technologies that sound impossible today, it's worth paying attention. Not because every patent becomes a product, but because every breakthrough begins as an idea. Maybe the most important lesson isn't that China has patented the future. Maybe it's that the future is already being designed, quietly, long before most of us ever hear about it. And by the time those technologies finally reach consumers, the real race may have started years earlier, hidden inside laboratories, engineering teams, and patent offices around the world. That's why the next decade won't simply be defined by who launches the next AI chatbot, or who releases the fastest chip. It will be defined by who builds the technologies that everyone else depends on. And judging by the direction of today's research, that competition is only just beginning. If you enjoy exploring the technology stories hiding behind the headlines, the ones that explain not just what's happening, but why it matters, then you're in the right place. Consider subscribing, because the next breakthrough that changes the world probably won't arrive with a warning. And when it does, we'll be here to break it down together. Until next time, stay curious,